In this video, I'm going to convert a number from binary to decimal. So first thing we'll do is we'll come up with a binary number that we can convert. And I'm going to use 8 bits. So let's go with 1, 1, 0, 1, 0, 1, 0, 1. This will be our number, and we're going to figure out what that equals in decimal. Now, in order to do this, we need to understand that binary is a base 2 numbering system. And the way that we count in binary is just with 2 bits. 0, 1, and in order to represent 2, since I can't use the number 2, I have to go with a 1, 0, and that equals 2. And then 1, 1, and then 1, 0, 0. So what happens here is once I've used a 1, the next time that needs to become a 0. And it always pushes things to the left until I've got these really long 1s and 0s numbers. But we need this to understand how computers think. So if this is 0 and 1 and 2 and 3 and 4 in our normal decimal system, we're going to be able to see that we can convert from this binary system over to our decimal system. Now, in order to do this, we need to understand that the value of each of these places is set to the same thing always. So for example, the value of just a 1 in this place equals to 1. A value of only a 1 in this place equals 2, and a value of only a 1 in this place equals 4. So what you can see happening here is a formula is being built here. 1, 2, 4, 8, 16, 32, 64, and 128. Every step of the way, we're doubling. We're doubling all the way up. Every bit is worth twice as much as the prior bit. So, in order to convert this over into our decimal equivalent, we can make a chart. And these numbers can keep going. 256, 512. It's not limited to 8 bits. It's not limited to the 8 places. You can keep going. 256, 512, 1024, etc., to make really big numbers. Just like when we're writing numbers in decimal, we don't end after 9. We can go up to 10 or 100 or 1000. So the numbers can get very long, but that's okay. We can still make this conversion work. So now I'm going to take my decimal number and I'm going to place it into this chart. 1, 1, 0, 1, 0, 1, 0, 1. And now what I'm going to do is every place where there's a 1, I'm going to take that number and I'm going to add it. I'm going to add up all those numbers. It's almost like coins of different denominations. If I have a quarter and a dime and a nickel and I add all of those together, it equals 40 cents. It's the same kind of thing here, but it's as if our coins were 128 and 64 and 16 and 4 and 1. So I'm going to take those numbers, I'm going to add them up, and 1. So I'm going to take these, I know they're equal to 10, there's 12 and 13, I'm going to carry 2 over to that second place, and 6 and 2 and 2, I know that equals up to 10, so I can carry 1 over there, and 213 is my number. So when all of that stuff gets added together, 213 is my end result. And that is the conversion from this binary number to this decimal number.